Welcome to Between Two Plants. We're excited for today's guest, Jaron Stanley, our VP of Process Engineering. I'm your host, Ian Fife, Executive Vice President of Sales. Jaron, we're excited to have you here today.
Thanks, Ian. It's good to be here.
What is a PhysChem lab?
PhysChem stands for physical chemical, and what we're doing is we're really doing solid liquid separation. So we're trying to remove solids from water.
Now, I understand there's three different types of labs that most people dealing with water treatment might interact with. Can you tell us a little about what those three different labs are?
Yeah, most people, when they're looking for a lab, they are expecting that they're going to be working with an analytical lab. And let's say you needed a water analysis. So you dug a well in your backyard and you wanted to find out, can I drink that water? You would take that water sample to an analytical lab and they would give you a report of all the constituents in the water, what's in there, what the quantities are, how much of it's in there, and they'll even tell you if it's within drinking water standards. That's not the service that we provide. Our service, so we'll go out to local analytical labs, and most people have an analytical lab near their location, and they can go to those labs and get the information they need. What we're looking to provide is specific information about your water and how we would go about treating it. And we do that both physical, chemical, and we also have a biological lab that focuses on treating water biologically.
Great. So would it be safe to say that a water analysis lab tells you what's in the water, but the PhysChem, the biological labs, tell you how to get stuff out of the water?
Yeah, that's a really good way of looking at it.
So tell me a little bit more about a biological lab and what types of services they might offer.
Sure. Our biological lab is focused on studying the biology in the water, so the bacteria, and seeing how they can use those bacteria to physically remove target contaminants. So we specifically focus on selenium and nitrates, but our biological lab can also study the bacterial populations. So most wastewater treatment plants are using bacteria to remove organic material. And depending on the type of bacteria, could change the quality of the treatment that they get. And it could also, if they have the wrong bacteria, it could cause problems with their treatment process. So one of the services our biological lab provides is studying those native populations and making suggestions about how you might go about changing those populations to get the treatment you're looking for.
So the biological lab grows bacteria?
It does. And it also has a library of bacteria that are specifically developed, or they're found natively. So they're found in water sources, but they have been shown to treat and remove certain chemicals or constituents in the water that need to be removed.
And in these cases, we like the biology, we like the bacteria.
In this case, they're doing the work for us. They're our friend.
Now, how does that differ then from a PhysChem lab?
On the PhysChem lab, we're using chemistry and physical separations to remove the things that we need to get out of the water. So if you imagine, if you just took a cup of water from a lake, it would probably be dirty. It has solids and it's suspended in the water. And we will use methods to try to get those solids out. We might try to separate it by gravity. We could also use filters to filter out or screen out those solids. But sometimes we can speed up that process by adding some chemistry. So adding coagulants and polymers. Sometimes there are things dissolved in the water. There are metals or salts that are dissolved in the water. If we can precipitate those, change those from dissolved to suspended, then we can use those same methods to remove them. And that's where the physical and the chemical come together.
And so some contaminants can only be removed biologically, whereas others can only be removed through physical or chemical processes. And that's why the need for the two different labs.
That's right. Or it might be more efficient to do it biologically versus chemically. It might be possible to do it both ways, but the end result might be a lot more complicated, where the biology might speed it up, or the physical chemical process might be the more efficient way to do it.
What are the specific types of testing that you do in the PhysChem lab, and maybe equipment or processes that you replicate?
Great. So every sample that comes in, we start with an initial characterization, and we're checking its vital stats, so to speak. So we're going to check its pH, temperature. We'll measure the TSS, TDS. TSS is total suspended solids. TDS is total dissolved solids. We can measure conductivity, and we can measure a handful of metals if there are specific targets that we know we're going to be trying to, or treatment targets. We might start by taking the initial, measuring the initial amount. Tests that we do in our lab include submutation tests. So that's the test that we use to size a full-scale thickener or clarifier. We do a lot of jar testing, which is where they call it jar testing. We have a device that has 6 mixing stations that are all identical with 6 different containers on it. And we can dose slightly different variations of chemical in each one to see a side-by-side comparison and to be able to get quick results about how small changes in chemical might change the treatment. So we'll do a lot of jar testing to determine chemicals that need to be done, need to be added for the process. Some of our tests, like ballasted flocculation, are done in a jar test, or chemical softening. So cold lime softening is often done as a jar test. We also have filtration tests. So we can test dewatering filters. We can test dissolved air flotation. We have a small benchtop UF system. We have a small benchtop filter press, and we also have bench scale pressure, or not pressure, but vacuum leaf filters for vacuum leaf testing. In our lab, we can measure particle size distribution, and we also do rheology testing for sizing paste thickeners.
You mentioned UF. I assume you mean ultrafiltration.
Thank you. Yes, ultrafiltration is you.
Right. So you can test various types of membranes, or I know we also have disc filters, which are kind of a membrane filtration. All those can be tested to see what rejection rates and things there are.
That's right. We have test procedures and apparatus to test a disc filter. We have different filter media for the disc filter, so we can see which filter media works best. We have tests to simulate incline plate separators, lamella type clarifiers.
So it seems logical that you would need a water analysis on any source to understand what is in it, because if you don't know what's in it, you don't know how to treat it. But do you need to do a lab test, a biological or a PhysChem lab test on every single water sample?
No. So a lot of times we try to let the water guide us, although we also like to know what our customers, what ideas they have for how to treat the water. So we'll start out, we'll always request an analysis of the water from an analytical lab. And based on that analysis, we'll start to formulate ideas of how we can treat this water. And then we'll decide, okay, does it make more sense to treat this using biological processes, or does it make more sense to treat this using physical chemical processes? Or it might be that the customer already has a goal in mind. They may have already said, this one, we really, because of whatever factors, we feel strongly that we need to take this down biological route. Can you test this to confirm? Or we have a pretty good idea that this physical chemical process will treat this water. Can you help us confirm that that's possible?
Now, a lot of customers have their own labs at their plants or on site. When would a customer consider doing in-house testing at their own site versus talking to someone like us?
That's a conversation that we can have with a customer. It depends on their capabilities and what they're used to doing. Most of the labs that our customers have are doing some high level analysis of the water. So a lot of times it's more like a quality control lab. They're really testing the water to ensure that it's meeting the requirements that they need for the downstream process. If they're discharging to a receiving body of water, or if they're producing water to be used in their plant or their process, they need to meet certain water quality criteria, and they'll usually test that to confirm. The testing that we do, we have some of that in-house capability just to ensure that along the way we're meeting those criteria. Um, but really, the testing that we're doing is trying to prove out different unit processes. So take a piece of equipment like a clarifier or a thickener or a filter. Our test methods are designed to simulate those processes and to give us the information we need to be able to scale up the design of that unit from this little benchtop test all the way up to a full scale piece of equipment that would be in plant.
Do you have to have testing performed in every scenario of sizing a piece of equipment that WesTech sells?
No, so the reality is a lot of this has been going on for a long time. People have been treating water for years and years, and we already have a pretty good idea based on our past experience what will work and what won't work. Um, and usually when we ask for a sample, it's because it's something that's new or different, or something that maybe we've seen it done before, but we're not sure if in this scenario it will behave exactly the same as we've seen in the past. And we just like to confirm that to make sure that our sizing will cover the various scenarios.
When would a customer consider doing a hybrid approach of doing kind of a combination of some in-house testing, but also working with our team?
So some of our customers are really early in their journey. They might be, it might be a new process that they're developing that they're not quite sure what the end result will be. So it's hard to give us a sample. Or maybe it's a brand new plant and it's just coming online. And they expect that during that startup period, the water will change. Um, and there are various other scenarios that kind of fit into that concept, but really when what we're looking for is if the samples we receive in our lab, they're a snapshot of the water. They're frozen in time. This is one sample. But if that sample is expected to change a lot, that's a scenario where you may want to do the testing on site and gather information on an ongoing basis to confirm, yeah, it'll work at the beginning, it'll work partway through the process, and it's still going to work towards the end. Um, in those cases, there are a few things we could do. We could go to site and we could do the testing on site rather than in our lab. We take the same equipment to the site. We'll ask the customer to be able to use some of their bench space, or we can even set up a table somewhere in the facility, and we'll do the testing there. The other option is we've even taught some customers how to collect some of the data. If the customer is comfortable with that, then we can arm them with enough information to be able to gather data for us, and then we can help them analyze that data to determine what size the equipment will need to be.
So let's specifically talk about when should a customer consider engaging with the lab that you run, the PhysChem lab.
If the customer is unsure, we will probably guide that conversation toward the lab. If as we go along we determine, this is something we really need to confirm with lab testing, we'll usually point the customer in that direction. So sometimes customers will come to us because they have regulations they have to meet. And those regulations say that they need to prove out the process, or they have investors that are holding back funding until they get some proof of concept. And in those cases, they might engage us initially to say, hey, can you run this in your lab and help us meet this need so that we can move to the next phase of our project?
Are there other specific scenarios in which we might require a customer to do lab testing?
Sure. A lot of times, if a customer is requiring a process performance guarantee, we really like to be able to do lab testing. Not in every case, but it gives us a higher level of assurance that the process will work.
So, Jaron, when the customer engages with you and with the lab to do testing, uh, what are you going to need from them?
Before we can accept any sample in our lab, we need a safety data sheet, an SDS. And most of our customers will say, well, this is water. I don't have an SDS for water. Well, that's okay. We need basically the same information that you would find on a safety data sheet. And what we'll do is we'll send you a letter and we ask you to respond to that letter. And that will give us the information we need as if we had an SDS. What that does is it tells us what known hazards are in the sample we're receiving to make sure that we're not going to expose any of our employees to an unsafe condition so they can have the right personal protective equipment for handling the sample. And so we know the proper methods of disposal of the sample. It also is a requirement from our fire marshal that we have SDSs for all of our samples so that if they ever have to come and help us, they know exactly what's in our lab at any given time. So SDS is probably the highest importance. We're going to ask for a lab testing information sheet. And what that does is it just makes sure we're on the same page on what the purpose of the testing is. So we're asking the customer to say, tell us what your goals are with this testing, what you're hoping to accomplish with the testing. We will also ask for a purchase order if the testing is being paid for by the customer. So we will also ask if we can have a water analysis before we start any testing. And that'll actually, usually before we even get to the point of receiving a sample, we'll give a proposal. And in that proposal phase, we'll ask questions about the water and we'll even request a water analysis if we haven't received one already so that we can understand what's in the water. And then we'll also ask, what are the goals, the treatment goals, so that we can establish those up front and start to make a plan for how we might go about accomplishing those treatment goals.
Jared, is there anything else a customer might need to provide as part of doing the lab analysis?
Yeah, part of that discovery process is also understanding what limitations the customer has. So before we start adding chemicals like inorganic coagulants, we need to know if that's going to be a problem for their downstream process, or if they have limits on how much of those chemicals can be added to their water, so that we don't give them a solution that doesn't match their overall capabilities in the plant. Also, if there are size constraints or other constraints on the physical plant or existing upstream and downstream equipment that might help inform a decision. Sometimes customers are trying to reuse equipment and they just don't know if their new process will work in the old equipment. By knowing more about the old equipment, we might be able to target our treatment process to fit in that existing equipment.
So I assume that means that every once in a while we expect to receive, or we might receive, a sample that has hazardous chemicals or contaminants within it. How does that change, or what happens in the case of hazardous materials?
We need to know that up front so that we make sure that our receiving processes are proper. And we also need to make sure that we can even receive and handle the sample in-house. There are some cases where we may not be properly equipped to handle the sample. So it depends on what the hazards are in the water that are making it hazardous. Once we receive the sample, we will follow the safety protocols. We'll establish and follow safety protocols. And that might be as simple as wearing gloves and eye protection, all the way to wearing full suits and performing the testing in a fume hood. One thing that we will ask customers with every sample is, will they take the sample back? We need to have a clear plan for how we dispose of the samples, and our preference is that the customer pays to take the sample back and dispose of it at their facility where the sample was created in the first place.
Jared, how much water is typically required to run an analysis? I assume it probably depends on the project, but is there a rule of thumb?
Yeah, most of our samples are shipped in 5-gallon buckets. They're shipped through, as long as they're not hazardous, they're shipped through standard shipping methods. So all the shippers that you're used to working with will take a 5-gallon bucket, or you can put it in a box and a 5-gallon bucket in a box. And usually we'll ask for 10 to 20 gallons for just the basic test. When test programs get more complicated, we've received multiple totes of water, and a tote is 270 to 320 gallons of water.
Is temperature a concern, especially when you're dealing with biology or other things in the water sample?
So one of the questions we ask in our sample information sheet is, what is the temperature of the process? Because we like to recreate those process conditions in our lab. So if the sample was hot when it was produced, and will be hot in the future process, we want to repeat those conditions, and we have heat baths to recreate that. One of the considerations we try to work through is, if a sample is hot and as it cools, it changes characteristics. If that can't be reversed by reheating the sample, that might be an indication that testing needs to be done on site with a fresh sample. So, for example, sometimes as samples cool, they will start a precipitation process, and they can be reheated, but that precipitation may not be reversible. That's a good example of when you might need to come to site to do testing of a fresh sample.
Sometimes I've heard of you guys receiving iced samples or samples that are shipped on ice. In what scenario would that make sense?
We ask customers if there's any possibility of biological activity. So sometimes surface water samples or wastewater samples can be biologically active, or if a sample has a large amount of organic carbon in the sample, those are situations where bacteria may grow and change the sample. And so we'll ask for those to be overnighted or rushed to our lab, and we'll ask for them to be shipped chilled but not frozen. Most people don't know this, but freezing a sample changes its characteristics. It changes the way the solids work, and although freezing it might preserve it, it will change its physical characteristics, and it won't be useful to us.
How would someone go about getting a sample delivered to you?
Most people will just take a 5-gallon bucket or any container that is sealable. And when we say 5-gallon bucket, we really highly recommend that you get one with a gasket in it. Not all lids have gaskets, and they will leak. So get a container that is sealable, and take that to your local shipper. So FedEx, UPS, DHL, even the US Postal Service, they have all shipped water samples to us. And just follow their procedures. They'll ask you the questions. They get cranky when your sample leaks on their packages, so make sure that it doesn't leak. Sometimes people will ship them in small containers that would fit inside of a cooler because they're used to doing that with analytical labs, and that's fine. But it's not necessary unless the sample needs to be shipped chilled.
What do you do with the water samples after you are done with them?
Great question. So we dispose of them through acceptable means and practices. So if the sample is considered clean and safe for the environment, most of those can be disposed of in our drain, in our lab facility. If the sample is questionable or if it is not safe to be disposed of, then we will either have the customer ship it back to their facility for disposal, um, or we will pay a hazardous disposal company to come and take the sample.
You alluded to this at one point as we were talking about when would a customer want to do on-site testing versus shipping a sample to our lab and having us do it here, and what are the drawbacks and upsides to both?
So a customer, if the sample will change in transit, or there's something about the sample that is unstable, that's a good time for us to consider testing on site. As long as the site has a good, safe place for us to do the testing. Examples of that are oxidations. So sometimes there are things like iron and manganese in the water that might not be oxidized when the sample is collected, but in transit, bouncing around in a bucket with air, as soon as it's exposed to air, it'll start to oxidize, and that'll change that characteristic. So if the goal of our testing is to include that oxidation step, we really need to start that testing right on site with a fresh sample. Sometimes if a process is precipitating or slowly changing with time, you can't stop that process, and it's better to test that sample on site when it's fresh and ready to go.
Is there a downside to doing it on site? Why would you not just always do it on site?
The cost is a little bit higher because we have to pay to have some of our lab employees on site. So that includes their travel and expenses in addition to their time. We're in the lab, we're really just paying for their time to do the testing. The other disadvantage to us is that although most of our equipment can be shipped to site, it's hard for us to take all of the equipment that we would normally have in the lab. So it's a little more convenient for us to be able to do the testing on our home turf where we're comfortable and familiar and have everything at our disposal that we're used to having. But we've done we do a lot of testing on site on the customer side. So we'll start a conversation about that. There are equipment that we can't bring with us, drying ovens and micro pan balances. They just don't travel well, or they're big and bulky. Our preference is if the customer already has that in their own lab, we'll ask about that. We love to be able to use it. If not, there are ways that we can work around it, but it may change some of our ability to gather the same data.
Jaron, does WesTech use proprietary chemicals? You mentioned jar testing. Do you have your own suite of chemicals that you use, or what chemicals do you use for jar testing?
Well, WesTech is not a chemical supplier. We will provide chemicals for our operations, but we work with local chemical suppliers around the company. So we have a library of chemicals supplied by major chemical suppliers, and we will use their chemicals in-house to try to figure out what will work. What we found is that, for example, an aniline polymer by one company there will be an equivalent from another supplier. So whether or not we test the exact chemicals that the customer may be working with on their site, they'll be able to find something equivalent to it. And the chemicals we use, the suppliers have given us enough information that we can provide with our testing reports that the customer will be able to find out an equivalent product if they can't get that exact product. We'll also use inorganic coagulants, and we'll use some proprietary organic coagulants as well. And we'll give as much information about those, including the dosages and the concentrations that we use to get the treatment results so that can be reproduced on the customer's side.
If a customer has chemicals that they're already familiar with and use at their site, and they want to see how those specifically work in the testing, Can they send or provide you with that list of chemicals for you to replicate and use in the lab testing?
Yeah, absolutely. If we already have those chemicals in our lab, then yeah, definitely we will use them. Otherwise, we have a recent example where we asked for a contact and we reached out to the customer's chemical supplier and used they sent us samples of their chemicals so that we could test them in our lab. We've also had situations where when we've gone to site to do testing, we've met up with the customer's chemical supplier and we've worked together to find the right chemistry for the water treatment.
So really it's about doing what's best for the customer and finding out what's going to work best for the application.
Yeah, definitely. That's our main goal.
Who are your typical customers that you see most often that you're doing lab testing for?
I'd say the majority of the testing we do in our lab is for industrial customers. We've done a lot for mining, power. We've done some food and beverage type samples. Um, but we do occasionally also test drinking water samples. It's very rare, but it has happened that we've tested municipal wastewater samples. But it's not very common. Those tend to be the data surrounding sizing municipal wastewater equipment is very well established, and it's pretty rare that testing needs to be done there.
Jaron, what is the advantage of using the WesTech lab?
One of the main advantages is it gets us involved in your process. So our lab has lab employees, but we're connected to a team of process engineers. And when we receive a sample, we get that much more involved in your project and we'll get our process engineers involved. And we're all invested in trying to make this a successful project. So when you engage our lab, you're really engaging WesTech on a deeper level than you might otherwise get. And it provides the opportunity to learn about your sample and to improve the overall outcome of your projects.
Where is the PhysChem and the biological labs located?
They're both located here in Salt Lake City.
Are customers able to either see testing in process or at least come and visit the labs and see what they're about?
Absolutely. We love having customers come and visit. We'll set you up with a desk. We'll show you around WesTech, and you can come for as much or as little of the testing as you'd like. Really, we want you to feel comfortable with your process. I've had customers who've been really excited and they wanted to touch the slurry that we produce. They're like, I've never seen what that looks like at this stage. Can I physically handle it or, see what that's like? So it provides a very different experience when you can see what happens and see that in person. It can provide a level of confidence.
Jaron, thank you for joining us today. We appreciate your time, and it was great to learn more about WesTech's in-house lab capabilities, both biological and PhysChem. And we look forward to sharing more of this information with our customer.
Thank you, Ian. It's been a pleasure. I really appreciate it.